Hi everyone, welcome again to another video of SAT Math is Easy or SAT Math Explained. Today our topic will be one variable data, distributions, and measures of tensor and spread. That might sound like a difficult topic or something that's going to be extensive, but it's mainly just going to be mean, median, range, and mode. And if you don't know what that is, I'm going to go over that and some examples of it. And by the way, this is within the problem solving and data analysis domain. And let's just get straight to it. So what do you need to know? So, like I said, one of the main parts is median, range, mean, and mode. So it's important to know those. So I'm just gonna do a quick summary. So the median is basically the middle value. So mid value, the middle value. So I've have like let's say 2, 4, 6, 8, 9, 2, 4, 6, 8, 10. The middle value would be 6 because there's 2 on the left, 2 on the right, so it's the middle value. Let's say there was only 4 numbers, so let's say it was just 2, 4, 6, 8. The middle value would actually the median would actually be 5. It would be in the middle of the two middle values, the average of the two middle values. Speaking of average, that takes us. Never mind. We're gonna go to range. So the range is basically just the range of values. So the same example, let's say 2, 4, 6, 8. The range would be basically the biggest value minus the smallest value, so 8 minus 2. The range is equal to 6. And then, like I was saying, the mean is just the average. So the average, you just add them. So 2 plus 4 is 6, 6 plus 6, 12, 12 plus 8 is 20, and divide by the total number. So 20 divided by 4 would be 5. There's 5. 5 is the mean. And I'm going to show you guys how to do that with decimals later on. But the mode is basically the number that appears most frequently. So this one actually doesn't have a mode because 2, 4, 6, 8, all of them appear once, so there isn't really any mode. Yeah. So I just make sure, yeah, there is no mode if every number appears the same amount of times. So it's not like gonna be, oh, all of them are the mode. There just isn't a mode. Yeah, so that's it, median, range, mean, mode. It's good to know. So you just need to know how to apply this knowledge to solve for the missing numbers. So sometimes it's just going to give you like a data set like that, or you have to interpret like a table or something like that. It's gonna say find the median, find the range, something like that. Sometimes they're going to ask you to apply the knowledge. So they're going to give you the data set with like, it's going to be like comma x. Then it's going to tell you the mean is this. What is the value of x or something like that. Then you have to use the knowledge of the definition of these to solve for the missing number or the missing value. A good thing to know is outliers affect mean more than median. So sometimes there's going to be like questions with a bunch of data sets and asking you which one like to compare the mean and median. So basically, a good thing to know is that the mean is impacted more by outliers than the median. So let's say that you have like one that is like 2, 4, 6, and then and then yeah, and then it tells you that they add a fourth number, which is like 20. Which one is the mean or the median going to be higher? Then from here, there's an outlier. So the outlier is going to affect mean more. So mean is going to change or increase more than the median. Or let's say if it was negative 20, mean would decrease more than the median. Same thing. So mean is impacted more by outliers than the median. And it depends on which direction, if it's in the negative or the positive direction. A good thing, these will pop up. Box plots, dot plots, and histograms. Those are the three types of diagrams, as well as tables that will pop up. Tables are easy to understand, which is the next part. But box plots, dot plots, and histograms. So a dot plot and histograms are very similar. It's basically just like a number on the bottom and then its frequency on top, like on a table. This one is just of some value on the bottom. So here's number of brothers and sisters, and then the frequency is represented in dots. So this is 2 frequency, 3 frequency, 5 frequency. This one, instead of dots, they make a bar graph. So from 20 to 30, there's 2 frequency. And you also have to, you have to notice for histograms, it's going to be like any number from 20 to 30 appears 2 times. Any number from 30 to 40 appears 4 times. So it's important to note that. So it's like a range of values. A range from 20 to 30 appears 2 times, and so on. And the box plot, I'm not going to go. This one's going to take a couple minutes to explain it. So if you guys want, I posted a YouTube video explaining the whole thing. It's like the explanation is 3 minutes and a 2-minute example. So if you guys want, you can just pause the video, go watch that. But yeah, so let's move on. Like I said, interpret tables. They might give you a table, or you might have a table that, and you might either the question is going to be a table, ask you for like one of the mean, median, something like that, or maybe the answer options are tables. This only popped up for me once on the SAT, and it's a standard deviation question. So it's just good to know because it's like a free 10 points if you know it. Basically, standard deviation, or 10 or 20 points, I'm not sure. Standard deviation measures variety. So basically, a higher variety means a higher standard deviation. That's literally it. So standard deviation, if I have like 1, 2, 1, 2, 2, 2, and 5, that is my data set. Or I have 1, 2, 3, 4, 5. This one has a higher standard deviation because it has more variety. That's literally it. So it's good to know, just know the definition of it because it might give you 10 or 20 points. And use Desmos. I'm going to show you guys right now how to use Desmos. Just give me a minute to bring it up. Okay. So Desmos is not going to help you with mode and range, but for median and mean, you can literally just type median, parentheses, type the number 5, 6, 7, 8. It'll give you the median. And the same thing if you want to do the mean for that, mean of 5, 6, 7, 8, 6.5. You can separate it by commas. Like it's very like flexible. Like I don't understand. You want to add spaces, you don't want to add spaces. Like I don't understand. So yeah, so it's smart like that. So you can use median and mean like that. And just make sure, like, I'm going to show an example of that later on, but if there's a frequency, so let's say like 5 appears 5 times, you can't, like, you have to either put 5, like, you have to put 5 times for this. Sorry. You have to put 5 times for this, or you could just write it out, like, 25 and then divide it by 5. You guys, I'll show the example later on. But basically, just make sure that you can't just assume, okay, the frequency 5, comma 5, comma 5. I'm just gonna put 25. You can't do that. You have to list them one by one if you want to use this quick trick. So let's just go back to the whiteboard. Okay, so now how do you solve these questions? These questions do vary a lot. Basically, understand what information is given and how can it be used. So, how is the information given? Is it a data set? Do you need to like read one of the box plots or dot plots or dot plots or histograms, or is it like given in a table? How is the information given? How can I use it? And then what is it asking for? What does it want? Does it want the median, the mean? Does it want me to compare median or mean? Does it want me to solve for a missing value? And so on. So just understand what it wants and just use skills. There's nothing much I can add for how to solve. Just use all these and then understand what the question is asking for and what information is given. So that's it for the explanation. Let's move on to examples. As usual, please make sure to try the equations on your sorry, not equations, the examples on your own before watching me explain, because you will not learn from watching me explain anything. You'll just gain a false sense of understanding. So as usual, we do 2 easy questions, 2 medium questions, 1 hard question, and let's get started. So this one, I see there's 2 data sets. I automatically see an X, so I feel like we're gonna have to solve it. It tells us that data set A, solve for the missing value. It tells us that data set A and data set B each contain 5 numbers. If the mean of data set A, so the average, is equal to the mean of data set B, what is the value of X? Okay. So first things first, let's just find the mean of data set A so that we can try to implement it in data set B. So let me just open Desmos. Okay. So for data set A, just put it in the same way. Mean 72, comma 73, comma 73, comma 76, comma 76. I mean, if you don't want to do this, you could technically add them. It's plus 70, 72, plus 73, plus 73, plus 76, plus 76, divided by the 5 numbers. You get same answer. This would be useful if, like I said, if you have the frequency thing, and I'll show an example of that later. But yeah, so the mean for data set A is 74, and then we know that the mean is equal. So both of them have a mean of 74. 74. And then remember, so for this one, you have to first write it down before using Desmos, because Desmos doesn't let you like put a like equation, like put the mean of this is equal to this, and it's gonna solve for the variable. It's not gonna do that for you. So how do you find the mean? Let's just add all the numbers. So 61 plus 64. So we're gonna like kind of set up an equation. Plus 74 plus 85 plus x, and that is all divided by 5 because we're finding the average. And then we set it equal to the number we found. We set it equal to 74. And from there we can we can work to solve for x. So multiply both sides by 5 times 5 times 5. I'm going to use Desmos for that. 74 times 5. It's like 380, 370. So 370 is equal to 61 plus 64 plus 74 plus 85. I'm going to add these numbers. I'm going to add all the constants. I'm going to combine like terms, okay? So 61 plus 64, 61 plus 64. I know it's not showing for you guys. I'm just putting it into Desmos. Plus 85. So I get 284. So it's equal to 284 plus x. 284 plus x. From there, I'm just going to subtract 284 from both sides. So minus 284, minus 284. And then you put that into Desmos, you should get 96. So 96 is equal to x. And is that an answer option? It is not an answer option. So 16 plus 70. 16 plus 70 is 86. My bad, guys. So it's 86. That's why you should always use Desmos. So x is equal to 86. X is equal to 86. So like if this was a free response, I would have gotten it right just because I didn't want to use Desmos. So you guys always make sure to use Desmos for something like this, just to make sure you don't make a mistake. The second easy question tells us for quality control, first thing there's a graph basically, and it says number of defective light bulbs. So for each quality control, a company that manufactures light bulbs conducted 5 different trials. In each trial, 500 different light bulbs were tested. The bar graph above shows the number of defective light bulbs found in each trial. What is the mean number of defective light bulbs for the 5 trial? So this one, it looks like a lot. There's a lot of words, but at the end it just asks the mean number of defective light bulbs in all for the 5 trials. So just get the number of defective light bulbs in each trial, and then find the mean. So for A, so it's 4. Number of defective light bulbs is on the y-axis. So for A, it's 4. This for B, it's 7. For C, it's just that is not a 7. For C, it's just 1. For D, it is 3. And for E, it is 6. Then from there, you just go ahead, you open Desmos. Again, you can do it manually, but I don't see why you would do that. You just put mean 4, 7, 1, 3, 6, and the answer is 4.2. 4.2. So I know these two were mean, but there will always be other questions like median, mode, and range questions. But yeah, for these, it is all just mean questions. Okay, so moving on to the medium questions. Again, just make sure you guys are trying the questions before watching my explanation. This one, there's another table. It tells us that the results of 2 independent surveys are shown in the table below. We have 2 groups. It gives us sample size, mean, and standard deviation. Again, standard deviation is variety, the variety of the data set, the variety of the values. So it asks us which statement is true about the table. So we're just going to read each one and either say it's wrong or say it's right. So this one says that the group A data set was identical to group B data set. So it might say, okay, let me look. There's the same sample size, and the mean is the same. It must be the same. But then you look, there's a standard deviation is differing, and so standard deviation is variety. So we know that group B had more variety, which means they had different data sets, and it's by a big amount. It's like by almost 7. So this one is incorrect. Number A is wrong. Not number, letter A is wrong. So then this one tells us that group B contained the tallest participant. So they're basing that off of the standard deviation. You're seeing how the standard deviation is higher. So you could assume that, but maybe it was just an out. Maybe like A had an outlier, but everything else was like close together. So you can't technically assume that. This one tells us that the height. So this one is also wrong because like although standard deviation is higher, you might have had like I'm just gonna put my number. Let's say you had like 1, comma 2, 2, comma 2, comma 2, and then the tallest guy was like let's say 5 meters. I know that's a lot. So that's gonna be little standard deviation, but it still has the tallest number. What if this guy was like 1, comma 1, comma 2, comma 2, comma 3, comma 4? Like that has more standard deviation, although it does not have the tallest number. So we can refute B. Let me just erase that. Yeah, so we can refute B. So then moving on to C, this one tells us the heights of the men in group B had a larger spread than the heights of the men in group A. Group B had the greatest standard deviation. That does mean that they're going to have a larger spread. So this one does make sense. But let's just check with the last one. The last one says the median height of group B is larger than the median height of group A. So the median is height of group B is larger than the median height of group A. You can't really assume anything about the median having the mean and the standard deviation because the mean is the same and then the standard deviation is um, although the standard deviation is different, like I said in the beginning, the median isn't impacted by outliers as much as the mean. So you can't really assume anything about the median from here. You just have this. And let's say you're not sure if you could assume anything about the median. You just see that, like, if you're sure about one and you're unsure about D, then you can just, it's the one that you're sure about. Like, don't overthink it. Okay. So for this question, it tells you which of the following data sets in the mean is the mean greater than the median? Is the mean greater than the median? So you can remember what we said in the beginning. Like, before even looking at the answer option, you just remember most likely it's going to be testing this, or it's not going to be testing, but a way to find is that outliers affect mean more than median. So what does that mean? If we look for one with the outlier that's a lot bigger, we can know that it's most likely the mean is going to be greater than the median without actually going through and calculating. Because if you wanted to calculate each one, you want to calculate the mean for this and then the median, and then you have to type in 9 digits and then for that and then find it. Then you got to move on. So you're gonna do that 8 times, and then you can't even copy paste. You have to write it down on the SAT. You can't copy paste. You're gonna have to write it out every single time. That's gonna take way too much time. On the SAT, you got to make sure that you're saving time. For this one, you automatically see 5 for option A. The mean is 5, and then the median is 5. The median is right here. The the mean is just going to be adding them, dividing by the total, which is going to have to be 5. For this one, it's also going to be similar to the one above. Like, the median will be right here. The median will be 40. The average will be around that because you're adding from 0 to 80, then dividing by 9. So yeah, it's going to be around 40. Yeah, it's going to be around 40. For this one, you see that there's an outlier right here, like 256, 512, compared to the 2468, 16. 256 and 512 are outliers. So you know that the mean is most likely greater. So you could automatically go with this. But then let's check D. This one's a bit confusing, number D. You have, like, let's just assume this one's 0. So 0, 100, 100. So you have 2 100s, 3 200s, 3 300s. So the median is going to be around here. And then the mean will also be around the same area, but most likely going to be less because we're sure. So this one, instead of just calculating for D, you're like I said last time, you're sure about option C, so you don't even have to check D. Like, it's not worth wasting the time to check for D. If you're 100% sure about C, just move on. Or not even 100%, just mostly sure, because it has to be greater because of the outliers. That's it. And if you guys want, we could let's just go ahead and just, like, prove it. Like, let's say you had extra time, you just want to make sure. Let me just delete the highlighter. So let's just check for this one, the bottom one. Is it showing for you guys? Okay. So let's just check for the bottom one for option D, if the mean is higher than the median. So we know that the median is already at 207. It's like the middle, 207. So then we want to find the mean of it. So mean of 7, comma 107, comma 107, 207, comma 307. So right here, it's really close. You get 195 for the mean and then 207 for the median. So, but because we're almost sure about this one, and let's say you're not sure, you could have done that to make sure. But overall, if you don't have time, just choose the one that's most likely the answer, which would be this, C. So that's it for the medium questions. We can now move on to the hard questions. So this question tells us that the mean score of 8 players in a basketball game. So mean means, mean is of 8 players in a basketball game was, sorry about the handwriting, was 14.5. Then, if the highest individual score is removed, the mean score of the remaining 7 players becomes 12 points. So they remove the eighth person. Well, let's say let's say the eighth person is the guy with the high score. They remove them from the data, and the mean score would go from 14.5 to 12 points. So what was the high score? So here, this one you have to just understand the relationship. So the mean is basically like, you add of all the points from all the players. So all points, let's say, all points divided by 8 is equal to 14.5, right? So now using this, if we multiply both sides by 8, so times 8, we can actually find the total number of points they all scored. So I'm just gonna plug that into, not plug it in. Just put 8 times 14, 8 times 14.5. I got the total. Let's change it to total is equal to, I forgot it. 116. The total point score was 116. So then we know that 116, so 116 total points, minus x, and we're going to say that x is the highest score. The highest score. So that is divided by 7 because we removed the highest score. So now there's only 7 players. It is equal to 12. And from there, we have to solve for x. So basically what you have to identify, you have to apply even the previous skills from the algebra domain to be able to recognize a pattern, recognize the scenario, understand the scenario, create an equation to solve. So this barely involves knowing mean. All you need to know for this one was the definition of a mean. Everything else was from the algebra domain. So that is how everything will become mixed on the SAT. So continuing on, so you solve for x. Let's start by isolating the term. So multiply both sides by 7 times 7. You get 12 times 7, which is 84. 84 is equal to 116 minus x. Subtract 116 from both sides, minus 116. You get 16 plus 16, you get 32. Negative 32 actually, because 84 minus 116. And that is equal to negative x. And then as expected, you should get a positive number. If you got a negative number, you did make probably a small mistake. But then you get x equals 32 points. So the highest score that we got, the highest score is 32 based on that. I don't think there's another way to solve this. If you guys do know another way to solve it, please just let me know in the comments. And yeah, that is it for that question, and that is it for the video. So that is it about one variable data distributions of and measures of center and spread. But basically, yeah. So if you guys want a specific topic, please let me know in the comments, and I'll make sure to post it. And yeah. So that is it. Thank you for watching, and bye. And if you guys could, please consider subscribing, liking, clicking the bell, and sharing. And thank you for watching.